6.4 is about rational exponents. So the first thing to do would be review what the word rational means. This is a pretty important word in math. A rational number can be expressed as the quotient of two integers. So for instance, negative 0.6 repeating, this is a rational number because I could write it as negative 2 over 3, or the quotient of two integers. Pi is not a rational number because I couldn't write it as an integer divided by another integer. So if rational numbers see that word ratio could be written as a ratio or a fraction, then today, rational exponents, we're looking at fractions in the exponents. So let's just recall the rules of exponents. If I have x squared times x to the third, well, think about what this means. I have 2x's times 3 more. Total, you have 5x's. So this is equivalent to x to the 5th power. The rule was if I have the same base, you can go ahead and just add the exponents. Second, if I have x squared to the 3rd power, this would be equivalent to x squared times x squared times x squared. So in the end, you have 6x's. And the rule was, if I have a power to a power, two exponents, I would just multiply those together. So to get x to the 6th, I could take 2 times 3 to get that exponent. On the third one, a couple different things you can do. So I have the same base. I could go ahead and add these exponents and say x to the negative 1 power, and then make that exponent positive. You could make the exponent positive right away, so that's what I'm going to do here. This would be x squared over x cubed. And the rule kind of is subtract your exponents. So if I look at 3 minus 2, well, 3 minus 2 is 1, so there's 1 more x in the denominator than there is in the numerator. Or you could think of it as, let's see, 2 minus 3 is negative 1, so I'd have an x to the negative 1 in the numerator, and then you'd make that positive to get 1 over x. So keeping these rules in mind, let's move forward. So it talks about, you don't necessarily want to memorize stuff, but the rules are important as you start looking at fractional exponents. So if I have x to the 1/2 times x to the 1/3, that might be hard to visualize what that looks like, but if I have the same base, the rule is I just have to add the exponents. Now, how do you add fractions? Well, you guessed it, we did that whole chapter on fractions, common denominator. So the common denominator of 2 and 3 is 6. So 1/2 is like 3 over 6. 1/3 is like 2 over 6. So in the end, this is equivalent to x to the 5/6. And that's your most simplified form. If I have two exponents, exponent to an exponent, the rule is you just multiply those. So this should be equivalent to x to the 1/2 times 1/3, and 1/2 times 1/3 would be 1/6. So this is equivalent to x to the 1/6 power. The last one, you could add your exponents. So if you wanted to, you could add those exponents, or I am going to make that negative 1/3 positive by bringing that term to the other side of the fraction. So now if I look, 1/2 is bigger than 1/3, so I'm going to do the top minus the bottom. 1/2 minus 1/3. And again, I need a common denominator. So x to the 3/6 minus 2/6, which would give me x to the 1/6. So now, if I consider this product right here, we looked at something like this a couple days ago. Could I multiply these together? So, we talked about I have an x to the 7th and an x. So I have an x to the 8th, but could I combine this under one radical? Well, the problem is this is a cube root, this is a square root. So we said since the indices are different, I can't really combine those terms. However, I could combine these if I use fractional exponents. So recall, the square root is just like the 1/2 power. So I have x to the 7th, and if I'm taking the square root of that, it's like raising this to the 1/2 power. And then I have x to the 1/3 power. That's the same as the cube root. Now I'm going to multiply my exponents together. So 7 times 1/2 would be just 7/2. And I have x to the 1/3. If I have the same base, so as long as my base is the same, I can go ahead and add the exponents. And I'm going to need a common denominator. So the process of getting the common denominator is written there in pink. Multiply by something equivalent to 1. And I should have 21 over 6 would be equivalent to 7/2. And 6 over 6, or 2 over 6, excuse me, would be equivalent to 1/3. Now that I have the same base, I can go ahead and add my exponent. So this would be x to the 23rd over 6 power. So, okay, I couldn't combine these under the same radical originally because I had different indices, but if I use rational exponents, I ended up combining them. So the last part here is, could I rewrite this then as a radical expression? Well, sure. So this is like saying x to the 23rd to the 1/6 power, or the 6th root of x to the 23rd. And then if you think of what we did last week, or the previous lessons, 6 divides into 23, what, 3 times evenly? So you might be thinking something like this, 6 root of x to the 18th, that's x cubed. And 6 divides into 23 3 times evenly with 5 left over. And this is how you could combine your original 2 radicals under one radical expression. Cool stuff. Okay, so let's step it up a little bit. This example might be a little tricky. I want to know what would go in the question mark to make this equation true. So maybe pause the video, see what you can come up with. So my first train of thought would be, well, maybe I want to write all of these as a base with an exponent. So instead of seeing that radical sign, let's use some rational exponents. Also, I notice I'm multiplying all these terms in the numerator and denominator, and I see x to the 1/2 divided by x to the 1/2. So since I'm multiplying everywhere, I can certainly cancel those. Anything divided by itself is 1. So I'm going to do that right away. And then with this term, the square root of x would just be the same as saying x to the 1/2 power. And then I've got this one in there, x to, I don't know what the exponent is. And then in the denominator, the 4th root is the same as the 1/4 power. And I want all of this to equal x, or x to the 1st power. So then think about what's happening here. If I'm multiplying terms with the same base, I could just go ahead and add my exponents. And then if I'm dividing by a term with that same base, I would subtract this 1/4. So from here, this is really what you're looking at. Your base is x, you're adding those exponents in the numerator, you're subtracting the exponent from the denominator. So if you go ahead and clean this up, well, I have x to some power should equal x to the 1st power. So really I have 1/2 plus whatever that unknown exponent is, minus 1/4 has to equal 1. If I get a common denominator, 1/2 is the same as 2/4. 2/4 minus 1/4 is 1/4. So 1/4 plus what is going to give me 1? That unknown exponent is 3/4. So this is what the exponent would have to be to make the original equation true. So now I want to look at evaluating an expression like this, where you have a number raised to a rational exponent. Here's the first step. You're going to want to split up the fraction. So you have 2 options. You could say this is the same as 16 to the 1/2 to the 3rd power. because 1/2 times 3 will give you 3/2. Or you could say this is the same as 16 cubed to the 1/2 power, because again, 3 times 1/2 is 3/2. Now let me ask you this. If you can't use a calculator, would you prefer to do 16 cubed and then take the square root of that? Or would you prefer to take the square root of 16 and then cube it? I'm hoping you went with this first option. It's better to make the number smaller first and then cube it, rather than make it bigger and try to take the square root. So if I go with this route, step 2, simplify what is inside the parentheses. So 16 to the 1/2 power is just like saying the square root of 16, or what number square root is 16? That would be 4. And don't forget there's this 3 on the outside. So 16 to the 1/2 is 4, and then I'm cubing that. And in step 3, evaluate with the exponent. So 4 cubed is 64. So 16 to the 3/2 power, this would be like saying 16 to the 1/2 power. So I should be getting a number bigger than 16 if I raise it to a power bigger than 1. And that number is 64. If you know your perfect squares, your perfect cubes, your perfect fourths, simplifying something like this becomes a lot easier. So with that in mind, why don't you try to write each of these expressions as a simplified fraction or decimal? Pause the video, give this a try, and then we'll compare. So first step, I broke apart that fraction. I know 81 to the 1/4 is 3, and 3 to the 5th, well, that would be 81 times 3 is 243. If I check my answer, go back to the beginning, 81 to the 5/4, this exponent is bigger than 1, so I should be getting out a number that's larger than 81. On the second one, my exponent is 3/5. So that's smaller than 1. I might be thinking this should be smaller than 32. Same process, break up your fraction. Negative 32 to the 1/5 is -2, because -2 to the 5th power is -32. And then cube -2 to get -8. You could certainly punch this into your calculator to check, but on a test or quiz, you probably won't be able to use your calculator. Another note on some common mistakes I see, this is negative, so some people think about flipping things, but you'd only flip if your exponent is negative. So if you want some extra practice with negative exponents, maybe give these two a try, pause the video again, see what you come up with, and then you compare with my answers. So there's certainly a variety of ways you could have approached these problems. I guess I first flipped the fraction so I could make that outer exponent positive. And then if I'm raising everything to the 2/3 power, I kind of split up that 2/3 power. For the y to the 12th to the 2/3, you just multiply those. So 2/3 of 12 is 8. And then here, 1,000 to the 1/3 is 10. 10 squared is 100. Negative 64 to the 1/3 is -4, and -4 squared is 16. And then I just simplified to get my final answer. On the second one, you could change that -1.5 into a fraction. And then your exponent is negative, so I brought all of this to the denominator. I'm not flipping the exponent, I'm just changing the sign on the exponent. So it's 9 still to the 3/2 in the denominator. Split up your exponent, 9 to the 1/2 is 3, and 3 cubed is 27, so 1/27.